Question 2, part C.
Question 2 part.
C.
So where's this is question number 2 part C. So question 2 part C states describe how sp hybridized orbitals are formed, right?
Yeah.
So it's the mixing of one, it's a mixing of one s and one p orbital. So it's the mixing of an s and a p orbital.
Yeah, so I got that one. I mean the next one.
Okay, just a second. To form two
Yeah.
sp hybridized orbitals, to form two sp, one second, let me just write it, hybrid orbitals. Now the next part is sketch a diagram to show that how two sp hybrid orbitals can form a sigma bond. So you just have to show that that's easy two sp hybridized orbitals, right? So I think in carbon that's happening. So you just have to draw a sigma bond. Like, what does an sp hybridized orbital look like? It looks so it's going to look, it doesn't look like this. One second. So it looks like this, one sp hybrid orbital, the other one looks like this, and they're going to overlap. So in the middle, they're going to start overlapping. It's just like a normal sigma bond. I'll just briefly go over the whole hybridization concept, and that is that carbon has 4 electrons. So in sp3, what happens is carbon is bonded to 4 atoms. So each orbital gets pulled in. They all get pulled in 4 different directions by 4 different atoms, right? So one pulling over here, one pulling over here. So that is your typical sp3 hybrid orbital. All 4 of them are sp3 hybrid orbitals. So that's a sp3 hybridization. What happens in sp2? In sp2, carbon is only bonded to 3 atoms. So the electrons, they get 3 of the electrons, they get pulled in 3 different directions. Again, the shape is kind of the same. It's the same kind of shape. So they all get pulled in. Just one second. So they all get pulled in 3 different directions, and the 4th orbital, which is a p orbital, it remains unchanged, and that's the one that's involved in pi bonding. So that's where the double bond comes from. And in sp hybridization, what happens is carbon is only bonded to 2 atoms. So what happens is 2 of its orbitals, they get pulled in 2 different directions by 2 different atoms. So 2 electrons of carbon are busy, one getting pulled in one direction, the other one getting pulled in the other direction. So carbon is left with 2 electrons in its p orbitals. So that is involved in pi bonding, and there's going to be another one which would be involved, and that's going to be on the z-axis. So there's going to be another one which would be involved in pi bonding, but that's your typical sp hybridized orbital. Now in this case, they were asking you to draw C2 minus 2 ion, C2 minus 2 ion. So they were asking you to draw that. So in that case, there were 2 carbon atoms. So carbon will have electrons. This carbon will be sp hybridized. This other one will also be sp hybridized, right? And so one of the sp orbital, which is getting pulled in this direction, the other one is getting pulled in this. So they're going to overlap in the middle, and they would form a sigma bond in the middle. Is that clear? In C2 minus 2, you've got 2 sp hybridized carbon atoms. So they were asking you to draw a sigma bond. So basically, you just have to draw. So when you get a question like this, you don't have to go into that much detail. You just need to know what a sigma bond looks like. Okay, so it's just going to be an end-to-end overlap of orbital. That's what a sigma bond looks like. Is that clear?
Yep.
And I'll just quickly see what shape are they looking for. So they're probably going to draw just a typical Oh, that's it. That's your typical sigma bond. One electron getting pulled in this direction, the other one getting pulled in the other direction. They're going to overlap in this middle part over here. So what's the next question?
So that was the only one I didn't get.
So ठीक है, किसी और का कोई और question तो नहीं है. We can start. We can start with the paper. Second.